Hello everyone. Today we are going to learn a very important and most frequently used measure of variability or measure of dispersion in statistics, that is standard deviation. We have read before the three different measures of variability or measures of dispersion, that is the range, interquartile range, and the variance. So today we are going to learn about the standard deviation. So I am going to tell you a very important information related to standard deviation, and today your concept related to standard deviation will be cleared. So first of all, what is standard deviation? Let's see what is the definition of the standard deviation. So standard deviation measures how spread out the data is. Now what does it mean? It means how much each value deviates from the mean value on average. So in order to understand this definition, let's have a small example, although I'll give you a detailed example a little bit later on, but a short example for you to understand the need of the standard deviation or what is actually the standard deviation is. For example, if we have a data set that is 10, 20 and 30. This is a data set. What we have to see, first of all, we have to see what is the mean of this data set. Mean of this data set is 20. So we need to see that how each value deviates from the mean. If I take this value, I will see how it deviates from the mean. I will take this value and see how it deviates from the mean, and this value as well. So what is their deviation? Or if we subtract these two values from together, we can say that 20 minus 10 is 10, 20 minus 10, 20 is 0, and 30 minus 20 is 10. So this is the deviation of each value. But we want to know that how much the entire data deviates from the mean on average. So in order to check that this deviation, the deviation of this entire data on average, we need standard deviation. It will tell you that how far the data is away from the mean, or the different data values are how they far away from the mean. So here the reference point is the mean value or the average. So we need to find that thing. This is the requirement of the standard deviation. When you can say this is the point where we need the standard deviation in order to check that how these values, all these values are deviating from the mean on average. So it will then tell once you get the standard deviation, it will tell you how spread the data is. Now how spread the data is, what does it mean? It actually quantify the dispersion, the measure of dispersion. Standard deviation basically quantify the measure of dispersion, that how dispersed the data is. But how we will come to know that what will be the value of standard deviation, and how we will evaluate that this value will correspond to high dispersion and this value correspond to low dispersion. Let's see the graph of different dispersions. Here we have a graph. One graph that is blue representing a data set of, this is data set 1, this is data set 2, and this is data set 3. So in order to check, this graph is showing the distribution of the data on the basis of the standard deviation and mean. If I say that in this graph, this is the mean and these points are far away from the mean on the basis of the standard deviation, whatever its value is. But here our concern is that the data 1 has the data values that are more near to mean, that are more concentrated near to mean, that most of the values are around mean. It means their standard deviation will be small, while in the data set 2 the data values are more away from the mean. As you can see here, if I highlight it further, that this is away from the mean more as compared to the data set 1. Then we have the third case, that is the data set 3, where values are more away from the mean as compared to the data set 1 and 2. It means when the data is more spread, your standard deviation will increase. If you get a standard deviation that is high, it means your data is more spread out. If your standard deviation is low, it means your data is more around the mean. So we can say that standard deviation quantify the dispersion. So we can say that the more the data spread out, greater its standard deviation. So we can say that here the order of the standard deviation, that is from higher to lower, is 3, then 2, and then 1. It means the data set 1 has the lowest standard deviation, while the data set 3 has the highest standard deviation. If anyone came to know about it, that the standard deviation is high or low, so what will be its purpose? Its purpose will be, if the data is more spread out, it will be less reliable. It will be less consistent. So you cannot predict the behavior on the basis of the given data. So we need a consistent data that is not much spread out and that has the values that are more around the mean. Another important concern related to standard deviation is the shape of the graph. Here we have a graph that is a bell curve. Bell curve is basically a graph of a data that is normally distributed. Now what is meant by normally distributed? The data is normal. It means that 50% of the data lies on one side of this bell curve. If I highlight here on this diagram, like this portion on the left side of the mean, this is the 50% of the data, and another portion is the another 50% of the data. So it means it is symmetrical. When you have a mean and 50% of the data lies on one side of the mean and the remaining 50% of the data lies on another side of the mean, then you can say that the data is normally distributed. You can say that data is symmetrical. Data is symmetrical around the mean. So for the standard deviation, or for the value of the standard deviation to be reliable, the data should be normally distributed. If the data is not normally distributed, then you cannot use standard deviation as a measure of variability. The graph is called a bell curve. If I write here a bell curve, because its shape looks like a bell, is representing a normal distribution, or you can say that if once the data is normally distributed, you can easily find its standard deviation. Now this was all about what is standard deviation. Now let's see the mathematical formula that how you can represent a standard deviation. So basically, standard deviation is related to the variance. But how? Standard deviation is represented by sigma or S. Now what is the difference between sigma or S is? Sigma is for the standard deviation of population, while S is for the standard deviation of sample, small s. So this is how they differentiate from each other. Now what is the formula of the standard deviation? Standard deviation is basically the square root of variance. Square root of variance. Standard deviation is the square root of variance. Now what is the formula of variance? Formula of variance is summation I is equals to 1 to n xi minus x dash whole square divided by n. So here we have xi. Xi represent each data value, x dash represent mean of population, and n is the total number of data values. So the main difference between the variance and standard deviation is this square root. The square root differentiate among them. So because of this square root, it is also known as root mean square of deviation from the mean. The variance is basically the mean square of deviations from the mean, while standard deviation is root mean square of deviations from the mean. So that's all from today's lecture. We will see a detailed example in the next lecture. Thank you.